Okay, page 5 of the communication notes, section 4, and we are going to talk about bounded buffers. And this is the general solution, so it generalizes double buffering to any number of buffers. And it's called bounded because there are a finite number of buffers, and so we're going to have an array of n of these buffers now, and each of these is going to be of size buff size, and the implementation, well, we will have an array of n buffers, and we will have semaphores. So empty will be initialized to n, whatever number of buffers you have, and full will be initialized to 0. And we'll have indices. So the tail, which is used for so it's a queue, so you always add at the end of the queue. Like when you join a line, you don't join at the front, you join at the end of the line. So that's the tail index will be 0, and that is for producers, and you remove from the head of the line, or you get served from the head of the line, and again they're going to both start at 0, and that will be for your consumers to use. So now we can have multiple producers and consumers in the general solution, and so we need mutexes. So the plural to indexes is indices, but I've looked this up, and the plural to mutexes seems to be mutexes. So there you go. So we've got a tail mutex, and we've got a head mutex, and that's so that we can have multiple producers and or consumers. Now they need to go through the buffers in the same order, and so there needs to be a mutex around the tail and the head index, because they're going to be sharing that between them. So for the implementation, I'm going to say C problem set 6 again, so you get to do this, and see also lab 4, and that's where you use the OS message queue. So that is the RTOS2 implementation of a bounded buffer. And next we're going to start looking at how big do your buffers need to be.